Okay. The basic idea was, if you see, if in the circuit you see that there are many number of series connected elements, okay, it is better to apply uh, mesh analysis. If there are more elements that are connected in parallel, then it is better to apply nodal analysis. Okay. So that is the basic idea. The basic idea for this thumb rule is that to reduce the number of equations, okay, that you have to solve. If you don't do this, no problem, you can still solve it. Okay. Then after this, we slowly moved into our next topic, that is the first theorem. Okay. Then we moved into source transformation. Okay. In source transformation, we discussed about 4 rules. Okay. Rule 1, if there is a number of series connected voltage sources, that can be converted into a equivalent voltage source. If there are number of parallel connected current sources, that can be converted into a single current source. Okay, because at the terminals all the effect will be added up. If there are n voltage source, the effect of this n voltage source, that will be added up at the terminals. Okay, at these two terminals, this and this one. Similarly, if there are current sources, all these currents will be getting added up. Again, using KCL, all this current will be added up. So you are adding that. So this is the first rule. Second rule, if the opposite thing happens, that means there is like parallel connected voltage sources. Okay. Can you just denote it using equivalent? No. This kind of connection is difficult. Okay. Or it should not be, this kind of connection should be avoided in any circuit because it will damage some of the components. I gave the example that this is a voltage source, let us say 10,000 volt. This is a 5 volt. Okay, the difference between these two, you can understand, 10,000 minus 5. And there is no resistance here which can consume that much amount of energy. So the current will flow in this direction. But this voltage source may not be capable to handle that much amount of current. Definitely, this voltage source should be capable because its capacity is 10,000 volt. But this may not be V1, so it will get damaged. Similarly, current sources. Okay, this may be of, let us say, 1 ampere. This may be of 1000 ampere. Okay, so this 1000 ampere current will try to flow through this current source. As a result, this current source may get damaged. So it's better, it's always advisable not to connect this kind of a in this configuration. Okay, this is only possible when these voltage sources, the parallelly connected voltage sources, are equal. Okay, then at the, let us say this is 5 volt, this is 5 volt, this is 5 volt, and you are considering ideal case. That means the internal resistances are also same. Okay, then at the terminals you will get 5 volt. So this type of connection is possible only when all the sources, all the voltage sources are of same value and same characteristics, internal characteristics. Similarly, current sources are there, they are connected in series. It is only possible if, let us say, all the current sources are of same value and same internal like resistances and everything. Then the net current will be 5 ampere. Okay, then it is possible. Otherwise, if there is mismatch, then you cannot connect in this. Third rule, uh, if there is a resistance that is connected in parallel to a voltage source, that is of no use, because what this voltage source will do, this voltage source will apply plus V here or 0 volt here. Okay, so the net potential difference will be plus V. Okay, between these two terminals. That is the main idea of a independent voltage source. It will try to maintain a same amount but constant voltage across the two terminals, okay, to which this VT is connected. But this node and this node are same. Again, this node are same. So whatever your circuit will be, you'll be connecting it here. Okay, so if there is this R resistance, it is of no use. Okay, this is of no use because the same voltage will be applied across these two terminals. Similarly, if the current source is there, this current source will will ensure that current I will flow through this circuit. Irrespective of the resistance, the current source will ensure that current I will be flowing across these two terminals, and you will be connecting your circuit across these two terminals. So this resistance is of no use. So equivalently, if such connection is there, that is a voltage source in parallel with resistance, you can consider this as a single voltage source. You can neglect the resistance. Similarly, if there is a current source and there is resistance in series with it, you can consider it as a single current source. You can neglect the resistance. Okay, third rule. And the fourth rule is means the most important one, that if there is a voltage source, there is resistance. The resistance is connected in series with the voltage source. Then how to convert it into a current source? You have to simply find out the current. That is, let us say if this is connected, let us say if this is short circuit, then how much current will flow? I will be equal to V by R. So this I will now act as a current source, and this resistance that was connected in series with the voltage source, now it will be connected in parallel. Reason, again, you cannot connect, this resistance cannot be connected in series with this current source because of this rule 3. In rule 3 we have seen that connecting the resistance in series with the current source is of no use. Okay, so the resistance will be connected in parallel to the current source. Similarly, if the current source is given, if the current source with a parallel resistance, this is given to you, can you convert it back to this part? Again, what is the voltage that will be? Again, this I will be flowing to the resistance. This is open circuit. Okay, I will be flowing to the resistance. So what will be the potential difference across this? IR, V equal to IR. Okay, so you can find out V equal to IR, Ohm's law. Okay, so this V will be connecting here, and the resistance will be connected in series with the voltage source. Okay, similar concept is also applicable for capacitor and resistor. Clear? Let me know. This is the first thing we did yesterday, source transformation. This we discussed in detail, and also the logic behind it. Okay, from where these rules are coming. Please let me know if you have any doubt. Otherwise, I will move to the next part. That means the Thevenin's theorem. Okay. Yeah. So the main aim of these two theorems, they can be used interchangeably. Okay. Thevenin's and Norton's. If you know Thevenin's, you can simply use the source transformation and get into Norton's. If you know Norton's, you can simply use source transformation and get into Thevenin's. Okay. So these two are very interrelated. What is the use? Why do you use Thevenin's and Norton's? I gave you an example yesterday that let us say there is a house wiring system. There is a complex house wiring that is there. That means the electricity is coming from the distribution unit. It is coming to your house, and in the house you are interested in, let us say, you have bought a new appliance. That appliance may be like an air conditioner, AC. Now you are interested in how much supply should be there to the AC, because the AC manufacturer has given you some specification that this much amount of current, this much amount of constant voltage should be there. So you are interested in ensuring that much amount of voltage and current to that particular AC. You are not interested in the house wiring system that has been done by some kind of engineer. Okay. So you don't require that knowledge of house wiring system. The only thing you need the information about is, let us say this is your AC. Now AC you can represent it in terms of a simple load. Now load in simple terms can be represented in terms of a resistance. Okay, that means some element, load means some element that is consuming energy. And I have already told you that there is a resistance and there is a voltage source, let us say there is a voltage source. Then current will flow through this. Let us say this is V, this is R. Okay, then power will be consumed by this resistance. Okay, what is the power dissipated? VI. Across this resistance, VI power will be dissipated. Again, I you can write it as VI is equal to V by R. So power will be V square by R. Put this value of I here. It will be V square by R or I. So I square R. In this way, you can represent the power consumed by the load. So any load, be it your AC, be it your like a simple ceiling fan, that you can represent in ideal way, you can represent using a load resistance because that is consuming energy. But Vishnu, you just right now concentrate on this class. College open date, you already know, you have been given that your reporting date is 14th, I think. Okay. Again, see whatever has been communicated to you. Okay, or whatever was told in the orientation. I think 14th, 14th, 15th. Okay. Please concentrate on the class now. So that much power will be consumed. So any kind of load you can represent in terms of a simple resistance. But in practical case, it is not the in practical case it is not the correct way of representing. There may be capacitive elements. There can be inductive elements. If some kind of a motor is there, okay, means like in the fan there is a motor. When there is a motor, you know there is magnetic fields. Okay, we will see in your future, you will understand how these things function. So whenever there is magnetic fields that is there in a particular appliance, this inductor come into picture. So that load where there is some kind of a magnetic field, you cannot simply represent it by R. R and L both will be required. And here complication comes. Whenever the load, this inductor capacitive things are there, the uh, complications come. That we will study in AC circuit. When we will study AC circuit, that we will study there. Okay. So the house wiring system is there, complex house wiring system, and there are two terminals, let us say, and in these two terminals you have to connect your own appliance. Let us say this is a fan. So you are interested in what is the voltage across this plus or minus, let us say, what is the voltage across this fan and what is the current flowing through this fan. That you have to control. If whatever is the maximum capacity, if the current flows beyond that value, your fan will be like damaged. Okay. So you are only interested in voltage and current. House wiring system, you don't know the information. So what this Thevenin's and Norton's theorem does, it produces an equivalent circuit, be it any kind of circuit inside this box, be it any kind of a complex circuit. Be it any kind of a complex circuit. What it will do, it will represent in terms of a voltage source and a resistance in series. Okay, so this complex circuit will be represented like this. And the outside thing will be there. That means here you are connecting your fan. So this is a voltage source. You don't know what is that. That will be given by the Thevenin's theorem, VT, VTH, and RTH. Okay. So this is a Thevenin's equivalent circuits. Thevenin's equivalent circuit. Norton's does almost the same thing. Instead of the voltage source, Norton's theorem gives you a current source and a resistance in parallel. So this is a Norton's equivalent circuit. And in these two terminals, whatever load will be connected. Okay. So these two. Now, if you know Thevenin's, using source transformation, you can get to this part. Again, source transformation means if you there is a voltage source in series, there is a current source. From that, you can get into there is a current. There is a voltage source and there is a resistance in series to it. Okay, that kind of a source you can convert it to a current source and a resistance in parallel to it. Okay, that you can do. So if you know Thevenin's theorem, you can get to the Norton's theorem just by applying source transformation. If you know Norton's theorem, you can get back to Thevenin's theorem just by applying source transformation. But still, we will see how to solve them individually. Okay, so this is the main idea. Some complex network, load resistance, that complex network you have to represent in terms of a voltage source and a resistance. Okay. So let us start with this basic circuit. That means what is your load? The load is, this is RL, the load. Let us say this denotes some kind of a fan or some kind of a light bulb, anything. Okay. Now this is the rest of the circuit. This is the rest of the circuit. We have to simplify the circuit. So the first step in simplifying this is to remove this load. Okay. We have to remove this load first. The first step, you have removed the load. There was the RL here, you have removed it. As a result, a open circuit has been created. There is an open circuit. Now, what is your aim? Your aim is to find out what is the voltage across these 2 points. What is that means? What is this VTH? Now, if this is an open circuit, let us say this is a closed path. This is a circuit. That means there is a closed path is there. That means current will be flowing through this. Now, since this is an open circuit, no current will be flowing through here because there is no closed path. For now, we have removed the load resistance. That means there is no closed path. Okay. So current will not flow through this path. Through the 4 ohm resistance, no current will flow. If no current is flowing through the 4 ohm resistance, then whatever voltage is there across these 2 terminals, the same voltage will be applied here because there is no voltage drop here. Let us say this is V. Okay, the same voltage V will be applied here because there is no current flowing through this 4 ohm resistance. As a result, there is no voltage drop across this 4 ohm resistance. Again, if this is 0 volt, this will also be 0 volt. Okay, so to find this VTH, okay, we have to find this voltage across this 6 ohm resistance. Okay. Now, how to apply this? How to find out what is the voltage across this 6 ohm resistance? That means you have to find the current. Let us say, what is the current flowing? Let us say I current is flowing through here. Then I will be equal to 30 volt divided by the net resistance. Again, this is the voltage. Again, Ohm's law, V equal to IR. So I will be equal to V by R. What is the voltage that you have applied? 30 volt. What is the net resistance? 2 resistances in series. So you can simply add them up. So 12 plus 6, that means 30 divided by 18. That much ampere current is flowing through here. 4 ohm is not coming into the picture because no current is flowing. That is not the part of a closed circuit. That's why 4 ohm is not coming into the picture. So this much amount of current is flowing. Okay, now we have to find out what is the voltage across this 6 ohm resistance. So current I, that means I is flowing through the 6 ohm resistance. Again, you will apply V equal to IR. So V you have to find out. I you already know, 30 by 18. This much amount of current multiplied by 6 ohm resistance. So 10 volt. Okay, so 10 volt. So this is 10 volt. This is, let us say, 0. Okay, so this same 10 volt will be applied here. So your VTH will be 10 volt. Let me know if you have any doubt. This is the first step in solving Thevenin's theorem. Let me know if you have any doubt here. Any doubt, please write it in the chat. You can unmute yourself. You can just let me know. It's clear. Okay. This is the first step. First step is to find VTH. Second step is to find RTH. That means what is the equivalent resistance, RTH. So for that, what you have to do, again, you have removed the load resistance, RL. That is removed. Till now it is removed. Now, if you look, so there's an open circuit. Second, the second thing to find RTH, you have to deactivate the sources. You have to deactivate the sources. The source that was there here was the voltage source. Now, deactivating a voltage source means you are replacing it with a short circuit. Deactivating a voltage source means you are replacing it with a short circuit, because we have already seen for ideal voltage source, the internal resistance is 0. Okay, it offers no resistance. So we are deactivating the source, voltage source means we have to replace it with a short circuit. If it was a current source, you have to replace it with a open circuit, because it has infinite resistance ideally. Okay, so the first step, you have to deactivate the voltage source. That means you have replaced with short circuit. Now you are looking into the circuit from these two open terminals, terminals A and B. From these two terminals A and B, you are looking into the circuit. If you do that, then what is the equivalent resistance of the circuit? That you have to find. That means if you are looking into the circuit, if you are going from this way, there is this 4 ohm resistance. Then two branches are happening, and each branch, in the first branch, there is a 12 ohm resistance, there is 6 ohm resistance. That means, let us say this is A, this is point A. The first thing you are facing is the 4 ohm resistance. Then there are two branches are happening. In one branch, there is a 12 ohm resistance, and in another branch, there is a 6 ohm resistance. Again, these two branches are getting added up here, and this is the B part. So between A and B, what is the resistance? 4 ohm resistance. Again, these two are in parallel. So what will be the equivalent resistance? 12 multiplied by 6. 12 plus 6. Okay. So this is the equivalent resistance of this parallel circuit. And this will be added with this is in series. You find the equivalent resistance. Then you add up with the 4 ohm resistance. Again, these are equivalent resistance that you are finding. So so this will result into 2. So 4 plus, this is result into 6. That's okay. So this equivalent resistance will be of 4 ohm. This will be of 4 ohm. So 4 and 4 and 4, the total will be 8 ohm. Okay. So the equivalent resistance, RTH, or Thevenin's equivalent resistance, that will be of 8 ohm for this particular circuit. The moment you have got this, now if you have any doubt, please let me know. So this is the second step. First step is to find VTH. Second step is to find RTH. If you have done this thing, then you have solved the problem. If you know VTH and RTH, then you have to simply connect the VTH like this, RTH in series with the VTH, and then you have to reconnect the load. The load you have removed. In the first step, you have removed the load. Now you are bringing back the load. Now this is simply a series circuit. Okay, so you are applying 10 volt, and this RTH and this load resistance are connected in series. So 8 plus 2, that is 10 ohm. So the net current will be 1 ampere. So 1 ampere current will be flowing, 1 ampere current will be flowing through this 2 ohm resistance. And what is the voltage across this 2 ohm resistance? That is the current flowing multiplied by the resistance value, that is 2 volt. So Vx, the voltage across this 2 ohm resistance, will be 2 volt. Okay. Now, if you have any doubt, we will move to a bit more complex problem. But if you know this particular way of solving, then everything will be easier. So let me just revise the steps. The first step will be you are removing the load resistance. So in place of the load resistance, there will be open circuit. Next, you are trying to find VTH. Okay. Third step, you have to find RTH, you have to first deactivate any kind of source. If it was a voltage source, you have to replace the voltage source with a short circuit. If it is a current source, you have to replace the current source with the open circuit. This is the second step. And you can find the load resistance, the equivalent resistance, RTH. The moment you got VTH and RTH, you just draw the Thevenin's equivalent circuit. That means RTH will be connected in series with the VTH, and you have to reconnect the load resistance. If you do that, it will be very simple. Simply find out what is the current flowing, and you can find out the voltage across the load also, but just by multiplying the current flowing multiplied by the resistance value, load resistance. Now, let us go into a bit more complex circuit. That means, okay, this circuit. The load resistance is this one. This R equal to 2 is the load resistance. Then the first step, step 1. Step 1 will be, first step, remove the load resistance. Second step, find the Thevenin's equivalent voltage, VTH. To do that, what you have to find, you have opened the circuit. Now you have to find what is the voltage across these two terminals. This is again similar to finding what is the voltage across these two terminals, because these are simply connected by a conducting material. There is no element here. So whatever the voltage is there across these two terminals, the same voltage will be applied across these two terminals. So you have to, then the main aim is to find the voltage across these two terminals. How to find that? You can simply use mesh analysis. There are two meshes. Forget about this part. Forget about this part. This part is of no use now. In this circuit, using mesh you can use mesh analysis. That means you can clearly identify two meshes, mesh 1 and mesh 2. That means now you have to, then what is the first step of mesh analysis? You have to consider some kind of an unknown current for each and every mesh. So let us say this is mesh 1, this is mesh 2. So you have assumed that current I1 is flowing through this mesh in clockwise direction, and current I2 is flowing through this mesh 2 in clockwise direction. Now write KVL equation. KVL for mesh 1. KVL for mesh 1. You have to move in clockwise direction. First you have to see what are the like the polarities, positive and negative sign. If there is a battery or a DC source, voltage source, then you can clearly identify, okay, this side is the positive, this side is negative. How about this resistance? How about this resistance? So for this resistance, you have assumed the current to flow in clockwise direction. So for this resistance, current will be flowing from higher potential to lower potential. Okay, so this will be plus, this will be minus, because in that way current is flowing. Similarly, if the current I1 is flowing through this path, then plus sign will be here, minus sign will be here, because again current direction is this. Current will be flowing from positive to negative sign. Here current direction is in this direction. Now what about this resistance, this 1 ohm resistance? Here this resistance is common to both mesh 1 and mesh 2. So there are two currents that is flowing here. According to your assumption, there will be two currents. One I1 will be flowing from top to bottom. This will be I1, and current I2 will be flowing from bottom to top. Now both the currents are unknown. You don't know in which direction the net current will be flowing. If I1 is greater than I2, then the current direction will be from top to bottom, and the current magnitude will be I1 minus I. If I1 is less than I2, then the current direction will be from bottom to top, and the magnitude of the current will be I2 minus I1, but both are unknown, so you cannot find this value. So our convention was, if you are writing the KVL equation for mesh 1, you have to consider that the current that is flowing through this particular mesh is the highest one. That means I1 will be greater than I2. Okay, in that case, the net current will be flowing from top to bottom. That means this one will be plus side, this will be negative side. Now you simply apply KVL. That means you move in clockwise direction and see which like sign you are encountering first. Let us first start with this 10-volt battery source. That means if you move in clockwise direction, you will be encountering the negative sign first, so minus 10 volt. Then this resistance, if you are moving in clockwise direction, you will be encountering the plus sign first, so plus. Now here you don't know the voltage, you know the resistance value, you know what current you have assumed. So the resistance value is 1 multiplied by the current is I1. So this is the voltage. Again, using Ohm's law, V equal to IR, you are finding the voltage across this 1 ohm resistance. Again, moving in clockwise direction, the next element you will be facing is this 1 ohm resistance. Again, you will be facing the plus sign first. So plus, resistance value is 1 multiplied by, now what is the net current that is flowing? The difference between I1 and I2. Next element will be this 1 ohm resistance. The first sign that you will encounter moving in clockwise direction will be plus sign. So plus 1 multiplied by I1, that will be equal to 0. So I1 plus I1 plus I1. So 3I1 minus I2, that will be equal to 10. So this is your first equation that is written here. Now we will apply KVL for mesh 2. KVL for mesh 2. Again, first you have to identify the plus and minus sign. So voltage source is clearly given plus and minus sign. Again, I2 will be flowing through this 2 ohm resistance. Current will be flowing in top to bottom. So it will flow from higher potential to lower potential. Similarly, through this 1 ohm resistance, current will be flowing from in this side. So this will be plus, this will be minus. Now from here, from this common 1 ohm resistance, now we have to consider that the I2 will be greater than all other currents. Okay, so the net direction of the current will be in bottom to top, and the magnitude will be I2 minus I1. Okay, if this is the current flowing direction, then this will be plus sign, this will be minus sign. Apply KVL for mesh 2, starting from, let us say, this 1 ohm resistance. So if you move in clockwise direction, you will be encountering the plus sign first. So plus 1 I2. Then you are encountering the 5 volt. So you are encountering the plus sign first. So plus 5, you are encountering the plus sign first. So plus 2 I2. Again, moving in clockwise direction, you are encountering the plus sign first. So plus 1 multiplied by I2 minus I1 will be equal to 0. Okay. If you simplify, it will be minus I1 plus 4I2. That will be equal to minus 5. Okay. This equation. So this is for mesh 1. This is for mesh 2. Now two equation, I1 and I2 are the two unknowns, and you have two equation. So two unknowns, two equation. By the knowledge of your solution of simultaneous equation, you can find out what is the value of I1 and I2. Okay, I1 will be 5 by 11, I2 will be minus 5 by 11. Okay. Now again, let us get back to the circuit. You have found I1, you have found I2 using mesh analysis. So you can see that I1 is I1 that you have considered is plus 5 by 11. Plus sign is there. That means whatever direction you have assumed for I1, that is correct. So the current will be flowing in clockwise direction and the value will be 5 by 11. For I2, it is minus 5 by 11. So whatever direction you have assumed, that is wrong. It is flowing in the opposite direction. So the current will be flowing in this direction. And the value of that current will be I2 will be equal to 5 by 11. So the current that will be flowing through this 2 ohm resistance will be in this direction. So it is 5 by 11. So what will be the voltage drop across this resistance? That will be resistance value 2 multiplied by 5 by 11. So it will be 10 by 11. So 10 by 11 volt. And what will be the plus minus sign? This will be plus side, this will be minus side. Because current will flow from higher potential to lower potential. So this voltage drop across this 2 ohm resistance will be of value 10 by 11 volt. Now you have to see that what is the potential difference across these two terminals. Here there is a 5 volt and in opposite direction there is a 10 by 11 volt. So the net potential across these two terminals will be 5 minus 10 by 11. So 55 minus 10 by 11, that will be equal to 45 by 11. So the net potential across these two terminals is 45 by 11 volt. And the same potential will be applied across these two terminals. So your VTH, the Thevenin's equivalence voltage will be 45 by 11 volt. Okay. Now, is it clear? I1 is 35 by 11. Please check. Okay. Again, it is a simple calculation from simultaneous equation. You can do it. Okay. The next step will be to find out the equivalent resistance. Okay, RTH. So to find RTH, the first step I have already told you, deactivate the voltage sources. Now, how many voltage sources are there? You can see there are two voltage sources. That means this 10 volt is there. To find out RTH, what you have to do? You have to replace this with a short circuit. You have to replace this with a short circuit. So that's what it has been done here. Now, the RL you have already removed. Okay, so the open circuit is there. Now here you have replaced with a short circuit. Here you have replaced with a short circuit. Now you are looking, let us say this is terminal A, this is terminal B. You are looking from these two terminals A and B, and you are trying to see that what is the equivalent resistance. Now, starting from this terminal A, what is the first thing that you are facing? There is a branching out happening. That means two branches are there. In one branch, there is 2 ohm resistance, and in the other branch, there is a 1 ohm resistance. This is 1 ohm, this is 2 ohm. Again, after 1 ohm, there is again a branching out. There is again a branching out. In one branch, there are two resistances. That means there is 1 ohm and there is 1 ohm. 1 ohm and 1 ohm. Okay. And the other branch, there is 1 ohm resistance. And these two are getting added up here. Again, this is getting added up to this 2 ohm resistance. This is getting added up to this 2 ohm resistance. And you are reaching the B terminal. What will be the equivalent resistance? What will be the equivalent resistance? First, you have to, one by one, you have to find out the equivalent resistance. So these two resistances are connected in series. So you can replace, there is a 1 ohm resistance, there is a 1 ohm resistance. You can replace it with a 2 ohm resistance. You can replace this with a 2 ohm resistance. Add them up. Resistances connected in series, you can add them up. Now, next, this 2 ohm and this 1 ohm are connected in parallel. So what will be the equivalent resistance? 2 multiplied by 1 divided by 2 plus 1. Okay, so 2 divided by 3. 2 divided by 3 will be the equivalent resistance. So you can replace these two things with a 2 by 3 resistance. Now, this resistance and this resistance are in series. So you can add them up. That means 2 by 3. What is the equivalent resistance? 1 plus 2 by 3. So 5 by 3. 5 by 3 resistance. So you can remove this part and replace with a 5 by 3 ohm resistance. Now this 5 by 3 and this 2 ohm are in parallel. So again, 5 by 3 multiplied by 2, 2 plus 5 by 3. So the net will be 10 by 11. So this will be nothing but 10 by 11 ohm. So your RTH, Thevenin's equivalent, RTH, also known as Thevenin's equivalent resistance. So this is your 10 by 11 ohm. Now if you know VTH and RTH, you have to simply connect the VTH here. This is VTH. VTH we have already found out. VTH is 45 by 11. And RTH we have already found by 10 by 11 ohm. So what will be the current flowing through this 2 ohm resistance? You have to add the RTH and RL. RTH is 10 ohm and RL is 2. Okay. So you can 22, 32 by 11. 32 by 11 ohm resistance. What is the current flowing? I will be the voltage, that means 45 by 11 divided by the total resistance 32 by 11. So 45 by 32. So this will be the current flowing through the load resistance. Now, if you have any doubt, let me know. If you have any doubt, let me know. Okay. So this is the basic idea of Thevenin's theorem. Now, if you know Thevenin's theorem, we will learn the Norton's theorem separately. But if you know Thevenin's theorem, can't you apply Norton's theorem? Can't you get a current source and a resistance in parallel to it? Yes, you can. You're simply using source transformation. Let us say the current I is flowing 45 by 32. This much amount of current flowing. So then that means this is the load resistance. Forget about this part. Okay. There is a voltage source. The voltage source is 45 by 11. And there is a resistance that is 32 by 11, I think, or 10 by 11, sorry, 10 by 11. can't you go from this to this? Using source transformation, you can. This current will be nothing but the current. If you, let us say, join this, then what will be the current flowing through this circuit? That will be voltage 45 by 11 divided by the current 10 by 11. Okay, so 4.5 ampere current will be flowing. The same current, you can write it as a current source for 4.5 ampere. And this resistance will now connected will be in, will be connected in parallel, that means 10 by 11. And you reconnect your load, that is 2 ohm resistance. So this will be your Norton's equivalent circuit. This will be your Thevenin's equivalent circuit. But Norton also we will learn separately. Okay. So there are other examples. There are a huge number of examples. So I have some things to discuss. So Ayush, I am unmuting you. Okay, you have some doubts, please clarify it. Okay, I am asking you to unmute. Sorry. Ayush Kumar.
Yes, sir.
Yes, you are mailing me and also you are sending some messages, I think.
Yes,
So
sir.
so you have doubt that you have joined late, so what will happen to your attendance? So
Yes,
what
sir. Yes, sir.
attendance will be counted after means your joining date, means from that date your attendance will be counted, and whatever the like you have to like 75%, 80% should be there. So your count will be from your joining date. And about what about the assignment? So so for those who joined late, I am already uploading all the video recordings. Okay, like you have joined after two weeks, let us say. So in 2 weeks,
Yes,
in
sir.
a week there are 4 classes. So you are already 8 classes behind. So it is difficult to take 8 extra classes, but
Yes,
the
sir.
recordings are there in the Google Classroom if you have joined. And I will take in a weekend, I will take an extra class. So just first go through the videos. Now, whatever your doubts are, just note them down, and I will take an extra class, multiple extra classes I will take for those who joined late, for those who missed some classes, or those who have doubts. In weekends, I will take those classes. Like I have to take the permission for that. Once I get the permission, I will take the extra classes on weekends, and then you can clarify whatever doubts you have. Okay. So I will try to take extra class on Sunday, let us say. Since you have joined late, you have to take those classes on Sundays, or if you have no problem, then after like working hours, like here everything gets closed down at 6, like the rooms and everything are closed. So it's difficult to take after evening. For Sunday, I have to take extra permission and I will take the extra classes. So just go through the lectures, go through the notes, and then I will take the extra class. Okay, Ayush.
Yes, sir. I am clearing the backlogs by seeing the previous recording.
Yes. And whatever your doubts are, you just can call me. I have already given the my phone number. Still, I am again giving 961
Sir, where can I get the recordings?
in Google Classroom. You have not joined Google Classroom? Okay.
No,
I'm giving you
no,
the
sir.
link right now. Right now, click on the link and join.
Excuse me, sir.
Yes.
Sir, I have only doubt about my previous attendance.
Okay. Which day? All the previous attendance.
No, sir. I have joined class after 23.
Okay.
Sir, me also joined after 23 spot round. Then my attendance, I also want to know about that.
So, so you didn't get the link, I think. For the first few classes, didn't get the link. That's the problem, I think.
Yes, sir.
Yes,
Yes, sir.
sir. Yes, sir. I am getting the link from yesterday.
Yes. So your attendance will be counted from the day you are getting the link, definitely, not before that. So I have given you the link, Google Classroom link. Please click on this link and join it ASAP. In the stream section, you can get all the videos and the lecture notes. Okay, here and also the assignment. So those who joined late, definitely I will take the extra classes and then you will submit the assignments. Okay. There is
Sir,
also, yeah.
I got my admission through spot round and my attendance when sir तो
So,
मेरा attend
yeah, your attendance will be counted from the day you are getting the link. Okay, before that, if you have not received the link, how can I count you absent? So if you are getting the attendance link from yesterday, so your attendance will be counted from yesterday. That means counted means you have to like satisfy the 75%, 80% attendance rule. So from yesterday that will be counted. Okay. मतलब कल
okay
से
sir
काउंट
but
होगा, जब जब से आपको लिंक मिलना शुरू हुआ है तब से आपका अटेंडेंस काउंट होगा। और जो भी चीजें आप मिस किए कर चुके हैं, यहाँ पे ज्वाइन कीजिए। यहाँ पे सारे वीडियो रिकॉर्डिंग्स और लेक्चर नोट्स गिवन है। उससे भी अगर डाउट होता है तो मैं एक्स्ट्रा क्लास लूंगा संडे को, या आफ्टर लाइक 6 PM आई विल टेक एक्स्ट्रा क्लासेस, यू ज्वाइन देयर एंड यू विल क्लैरिफाई, आई विल क्लैरिफाई योर डाउट्स। ओके,
okay sir
यस। So let me take the attendance quickly. It is 29th. A Vishnu. A Vishnu is present. Akash Rai. Akhil. Anag. Apurva Sinha. Arin. Ayush. Charanjit. Korsame. Nelson. Puthigan. Pratik Raj. Rajveer. Sasikamal. Soham Bhavesh. Austik Mishra. Yes, Vardhan. Okay, so I've noted your attendance. Please, from now on, please be regular in class. Many of you are still not attending. I can see from attendance. Please be regular. Whatever you have doubt, please let me know. But call me just, okay, or mail me. Okay, I'm ending the session. Okay.
sir is the hello sir
Yes, yes.
शशि कमल का
Recording
attendance हो गया ना
stopped.
sir
हो गया, सबका हो गया। जो जो प्रेजेंट है मैं सबका दे दिया हूँ, ठीक है।
okay, thank you sir
I'm ending the session. Go to your next class. Yes, yes, Anag. Yeah. I am talking
Sir,
about